Let me tell you something that most people are getting completely wrong about what just happened with China's rare earth export restrictions. They see the headlines about gallium and germanium controls, maybe they read about tungsten getting added to the list, and they think this is just another round of trade war escalation. It's tit for tat. China does something, America responds, the cycle continues. And on the surface, that logic makes total sense. Why wouldn't it be just another negotiating tactic? But here's where it gets interesting, and honestly, this completely flipped my understanding of how modern supply chain warfare actually works. This isn't a negotiating position. This is the activation of a weapon system that China has been building methodically for 30 years. And the reason most analysts are missing what's actually happening is because they're looking at rare earths as commodities. They're not commodities. They're the foundation of every single technology that defines military and economic power in the 21st century. Semiconductors, electric vehicles, wind turbines, missile guidance systems, fighter jet components, smartphone displays, every piece of hardware that separates a modern economy from an industrial one requires these elements. And China controls between 70 and 95% of global refined production, depending on which element you're measuring. Not mining, refining. That distinction matters enormously, and we'll come back to it. The United States right now has exactly one operating rare earth processing facility. One. And it sends its concentrate to China for final processing because there is nowhere else in the world with the industrial capacity to do it at scale. To understand why this situation represents something fundamentally different from normal trade disputes, you have to think about what supply chain dominance actually means at the strategic level. And the framework that explains this most clearly comes from something military theorists call structural dependence warfare. It's not about winning battles. It's not even about winning wars in the traditional sense. It's about creating conditions where your adversary cannot function without your cooperation, and then making that cooperation contingent on behavior you want to see. The genius of this approach is that it doesn't require military confrontation. It doesn't generate the domestic political costs that come with shooting wars. It operates at a level where most citizens don't even understand what's happening, which means there's no public pressure to respond aggressively. And critically, it's almost impossible to reverse quickly because the dependencies are built into physical infrastructure, supply chains, and industrial capacity that takes decades to develop. Think about how empires have historically maintained control. Rome didn't garrison every province with massive standing armies. That would have been impossibly expensive. Instead, they made provincial economies dependent on Roman trade networks, Roman currency, Roman legal frameworks. If you tried to break away, you didn't just face military retaliation. You faced economic collapse because your entire productive system was integrated into structures you didn't control. China has done the same thing with rare earth elements, except they've done it in an era where the industrial processes are so complex and capital intensive that reversing the dependency is exponentially harder than it was for ancient provinces. Let me walk you through exactly how this architecture was built, because the construction reveals the strategy. In the 1980s and 90s, rare earth mining and processing existed in multiple countries. The United States had significant domestic production. Australia had operations. Various countries in Southeast Asia had smaller facilities. These are not rare in terms of geological availability. The name is misleading. Rare earth elements exist in deposits all over the world. What's rare is the industrial capacity to extract them economically and process them into usable forms without generating environmental disasters. The processing involves extraordinarily toxic chemical processes, sulfuric acid baths, radioactive thorium separation, heavy metal contamination of groundwater. It's dirty, dangerous, expensive work with massive environmental cleanup costs. Starting in the late 1990s, China made a strategic decision. They would accept the environmental costs that Western countries were increasingly unwilling to bear. They would subsidize the industry heavily to undercut global competitors on price, and they would invest in the processing infrastructure at a scale that made economic competition impossible. Over 15 years, every major rare earth operation outside China either shut down because they couldn't compete on price or sold their concentrate to China for processing because that was the only economically viable option. By 2010, China controlled 97% of global rare earth production, not through military conquest, through patient economic strategy and willingness to absorb environmental costs that democracies with environmental regulations couldn't accept. The American political class noticed this occasionally. There were reports congressional hearings, statements about the need for supply chain diversification, and then nothing happened. Because here's the trap that most people miss. Building rare earth processing capacity isn't like building a factory. You can't just construct facilities and start production. The chemical engineering processes require specialized knowledge that exists primarily in China, because that's where the work has been done for 25 years. The equipment has to be custom built. The workforce needs training that takes years. The environmental permitting alone in the United States takes a decade if you're lucky. And most critically, even if you build a facility, you have to operate it profitably in a market where China can crater prices anytime they want by flooding supply. So, private companies won't invest the billions required without government guarantees. Governments won't provide guarantees because it looks like corporate welfare, and the whole system just perpetuates dependence. Now layer on top of that the fact that rare earth deposits often contain radioactive elements like thorium and uranium. In the United States, that means nuclear regulatory oversight, which adds another decade of permitting and billions in compliance costs. China's regulatory environment is different. They can move faster. They can accept higher risk. They can relocate populations if contamination spreads. The structural advantages compound. Here's what makes this particularly significant right now. The global economy is in the middle of the largest technological transformation since electrification. Electric vehicles require 5 to 10 times more rare earth elements than internal combustion vehicles. Wind turbines need massive amounts of neodymium for their magnets. Every smartphone, every laptop, every data center, every 5G network depends on rare earth components. Global demand is projected to increase 400% by 2035. At the same time, geopolitical tensions between the United States and China have reached levels not seen since the Cold War. Chip sanctions, technology export controls, military posturing around Taiwan, alliance building in the Indo-Pacific. And China is watching this and making a very rational calculation. If conflict is coming, if economic decoupling is inevitable, if the United States is going to try to strangle Chinese technology development through semiconductor restrictions, then why would China continue supplying the elements that make American weapon systems, American electric vehicles, American renewable energy infrastructure possible? The leverage is extraordinary, and unlike oil, where there are multiple major producers and strategic reserves can buffer supply shocks, rare earths have no equivalent backup system. Think about what happens when China restricts gallium and germanium exports, which they did in July 2023, and then expands that to tungsten, which happened in December 2025. Gallium is essential for semiconductors used in military applications, radar systems, electronic warfare, missile guidance, communications equipment. China produces 94% of global gallium. Germanium is critical for fiber optics, infrared imaging, solar cells, and high-efficiency semiconductors. China produces 83%. Tungsten is necessary for armor-piercing munitions, drill bits, industrial cutting tools, and various aerospace applications. China controls about 70% of tungsten processing. When export restrictions hit, the immediate effect isn't that everything stops. There are inventories. There are existing stockpiles. But every company that depends on these materials starts calculating how long their reserves last. They start trying to secure alternative suppliers and discover there aren't any at scale. They start planning production cuts or facility relocations. And the entire calculus of where you build things, where you invest, what products you can profitably produce starts shifting. Apple cannot manufacture iPhones without rare earth magnets in the speakers, cameras, and haptic feedback systems. Tesla cannot build electric motors without neodymium and dysprosium for the permanent magnets. Boeing cannot produce jet engines without rare earth elements in high-temperature alloys. The entire American industrial base is structurally dependent on China, continuing to export materials that China has every strategic reason to restrict. Now add to this something that makes the situation even more asymmetric. The United States has been working on rare earth supply chain diversification since at least 2019. The Mountain Pass mine in California reopened. There are processing facilities being planned in Texas. The Department of Defense has thrown money at the problem. Australia is trying to build capacity. But here's what nobody wants to say out loud. Even in the most optimistic scenarios, where every planned project comes online on schedule, with no delays or cost overruns, which never happens, the United States and its allies will not have sufficient domestic rare earth processing capacity to meet demand until sometime in the mid-2030s. That's a decade away. A decade during which China holds complete leverage over the materials that enable modern military systems and industrial production. And China knows this. They can read the same timelines. They can see the same projects. They know exactly how long the window of maximum leverage remains open. Let me show you what this looks like in concrete terms by walking through a scenario. Imagine China announces in response to some geopolitical trigger, doesn't really matter what, maybe new American chip export controls, maybe weapon sales to Taiwan, maybe something else entirely, that all exports of neodymium, dysprosium, and terbium are suspended indefinitely for national security reasons. These three elements are absolutely critical for permanent magnets used in everything from electric vehicle motors to wind turbines to guided missiles. Global stockpiles for most companies run about 3 to 6 months. Within 90 days, every major electric vehicle manufacturer is rationing motor production. Tesla, which builds about 500,000 vehicles per quarter, starts announcing production cuts. Ford's electric F-150 Lightning production slows. Rivian, Lucid, every EV startup in America and Europe faces the same constraint. They can't get the magnets. There are no alternative suppliers. The vehicles they've already built start getting more valuable because nobody knows when new production resumes. Used EV prices spike. New EV orders get waitlisted for years. And this is happening simultaneously in wind energy. New turbine production stops because you can't build a modern wind turbine without neodymium magnets. The entire renewable energy transition that Western governments have bet their climate policies on just hits a wall. Not because the technology doesn't work. Not because there's no demand. Because one country controls the materials and decided to turn off the tap. Now project this into the defense sector, and it gets genuinely disturbing. The F-35 fighter jet contains something like 400 pounds of rare earth elements per aircraft. Precision-guided munitions, advanced radar systems, electronic warfare pods, all of them require rare earth components. If China cuts exports, the United States military doesn't immediately lose capability because we have existing stockpiles and existing equipment. But production of new systems slows or stops. Replacement parts for existing systems become constrained. And every day that passes, the military inventory of rare, earth-dependent munitions depletes slightly, while replacement capacity remains frozen. You end up in a situation where the American military can probably still fight a short, intense war using existing stocks, but a sustained conflict that requires continuous munition production becomes logistically impossible. And China knows this calculus. They can see American stockpile levels, or at least estimate them with reasonable accuracy. They know how long the existing inventory lasts under different consumption scenarios. The strategic planning practically writes itself. But the implications cascade beyond just the immediate supply shock. Let's think about what this does to global investment patterns. If you're an automobile company deciding where to build your next electric vehicle factory, and you know that China controls the rare earth supply chain, where are you going to build? You're going to build in China or in countries that maintain good relationships with China, because that's where supply security exists. If you're a renewable energy company planning a wind farm, you're going to source turbines from manufacturers with guaranteed access to Chinese rare earth materials. If you're a defense contractor, you're going to be lobbying your government desperately for either strategic stockpiles or guaranteed rare earth supplies, which means government intervention in markets, which means massive public expenditure, which means debt. The entire logic of where industrial capacity locates starts shifting away from traditional considerations, like labor costs, proximity to markets, or regulatory environment, and toward a single question: can you guarantee access to rare earth materials? And the only place that can answer yes to that question with certainty is China, or countries in China's economic orbit. This creates a feedback loop that accelerates Chinese economic influence. Countries that want industrial development need rare earth access. Rare earth access requires good relationships with China. Good relationships with China require political accommodation on issues China cares about. Maybe that means not joining American-led technology alliances. Maybe it means staying neutral on Taiwan. Maybe it means adopting Huawei 5G infrastructure despite American security warnings. The rare earth leverage translates into political leverage, which translates into alliance erosion, which translates into reduced American strategic options. And this is all happening while the United States is trying to build a coalition to counter Chinese influence in the Indo-Pacific. You're asking countries to take economic risks by aligning against China at the exact moment when China controls the materials those countries need for their own industrial futures. The strategic bind is extraordinary. Now here's where it gets genuinely complicated, and this is something that should make American strategic planners deeply uncomfortable. The United States has historically responded to supply chain vulnerabilities by either securing alternative sources or developing substitute technologies. But rare earth elements are unique because they're defined by their atomic structure. You can't substitute your way out of needing them for certain applications. There is no synthetic replacement for neodymium in high-performance permanent magnets. You can try to develop motors that don't use rare earth magnets, and there are research programs trying to do exactly that. But the performance characteristics change. The motors get heavier, less efficient, more expensive. For some applications, that's acceptable. For others, particularly in aerospace and defense, where weight and performance are critical, it's not. So, the substitute technology pathway that has historically provided strategic resilience doesn't fully apply here. You're stuck with the physics of the periodic table. The alternative source pathway is theoretically possible, and it's what the United States and its allies are desperately pursuing, but it runs into the timeline problem we discussed earlier, plus a deeper issue. Even if America builds domestic processing capacity, where does the ore come from? The largest rare earth deposits outside China are in places like Myanmar, which is increasingly in China's sphere of influence, the Democratic Republic of Congo, which has minimal infrastructure and massive political instability, Greenland, which requires Danish cooperation and massive infrastructure investment in one of the most remote environments on Earth, and Australia, which is a reliable partner but still needs to build processing capacity that doesn't yet exist at scale. So you end up dependent on a supply chain that's only marginally less vulnerable than the current one. You've reduced dependence on Chinese processing, but you're still dependent on ore sources that China could potentially control through economic influence, or disrupt through support for regional instability, or simply outbid for through long-term contracts. The vulnerability doesn't disappear. It just shifts slightly. And there's another factor that deserves serious attention, but gets almost no discussion in mainstream analysis. The environmental cost of rare earth processing creates political vulnerability in democracies that authoritarian systems don't face. If the United States decides to massively scale domestic rare earth production, you're going to create significant environmental contamination. Radioactive waste, heavy metal pollution, water table contamination. Some of that is unavoidable given the chemistry involved. In China, if a region gets contaminated, the government can relocate populations, suppress media coverage, and continue operations. In the United States, you get lawsuits, EPA enforcement actions, congressional investigations, and public protests. The political cost of accepting Chinese levels of environmental damage is probably prohibitive in American democracy, which means either you accept higher production costs to meet environmental standards, which makes you economically uncompetitive, or you accept dependence on countries willing to bear those environmental costs, which brings you back to China. There's no clean escape from this bind. Let's zoom out and look at the broader systemic pattern here, because this isn't just about rare earths. This is about what happens when authoritarian state capitalism competes with market democracies in strategic industries. China can make 30-year investments in technologies and supply chains that won't show returns for decades because the state can allocate capital without needing to justify quarterly earnings to shareholders. They can absorb environmental costs that democracies won't accept because they don't have to win elections or face independent media scrutiny. They can coordinate industrial policy across thousands of companies through party control in ways that antitrust law prevents in the United States. And they can weaponize the resulting economic dependencies by restricting exports whenever strategic interests require it. The playing field isn't level. The governance structures create asymmetric advantages in long-term strategic competition. And rare earths are just the most visible example of a dynamic that applies to solar panels, battery production, pharmaceutical ingredients, telecommunications equipment, and multiple other sectors. What you're seeing is the activation of economic deterrence. Not military deterrence, where the threat is destruction. Economic deterrence, where the threat is that your economy stops functioning if you take actions the deterring power doesn't want you to take. Want to sell advanced weapons to Taiwan? Your electric vehicle industry collapses. Want to impose broader technology sanctions? Your renewable energy transition stops. Want to conduct freedom of navigation operations in the South China Sea? Your defense contractors can't get the materials to build replacement munitions. This is deterrence that operates at the level of industrial capacity rather than nuclear arsenals. And it's remarkably effective because the costs are immediate and tangible and affect domestic constituencies in ways that military posturing doesn't. A congressman whose district depends on an EV factory is going to think very differently about China policy when that factory is threatened with shutdown due to rare earth restrictions. Now here's what makes this particularly unsettling to analysts in Washington. The United States built its post-World War II global position partially on exactly this kind of leverage. The Bretton Woods system made the dollar central to global trade, oil markets denominated in dollars. If you wanted to participate in the global economy, you needed dollars, which meant you needed to maintain economic relationships that gave you access to dollars. That created enormous leverage for American foreign policy. Countries that angered the United States could be cut out of dollar-denominated trade, which was most of global trade. The rare earth situation is the inverse. China has created a position where if you want to participate in advanced manufacturing, renewable energy, or modern defense production, you need access to Chinese materials. And countries that anger China can be cut out of those supply chains. The leverage structure that defined American power for 70 years is being replicated with China at the center. And the United States is experiencing what it feels like to be on the dependent side of that equation. The truly strategic question, the one that should keep planners awake at night, is what happens when these dependencies collide with the Taiwan question. Because everything we've discussed becomes exponentially more acute if military conflict over Taiwan appears imminent or actually begins. In that scenario, China has absolutely no reason to continue supplying rare earths to countries supporting Taiwan or imposing sanctions on China. The economic warfare becomes total, and the United States would face a situation where prosecuting a war in defense of Taiwan requires munitions and systems that depend on materials China controls. You end up trying to fight a war against your own supplier, which is possibly the worst strategic position imaginable. The only historical parallel would be if Britain had been dependent on German coal during World War II. The logical absurdity of the situation would be almost comical if the stakes weren't so catastrophic. So, when you zoom all the way out and look at the complete picture, what you see is not a temporary trade dispute or a negotiating tactic that resolves through diplomacy. What you see is a structural shift in where economic leverage resides in the global system. For 30 years, China patiently built dominance in a sector that most Western policymakers didn't think mattered very much because it was small, dirty, and unglamorous. And now that dominance translates into the ability to constrain the industrial capacity, military capability, and strategic options of the United States and its allies. The trap wasn't built yesterday. It was built over 3 decades through patient industrial policy, while Western countries optimized for short-term economic efficiency and outsourced anything with environmental costs. The real question is not whether the United States can eventually rebuild domestic rare earth capacity. With enough time and money, probably yes. The question is, what happens during the 10 to 15 years between now and when that capacity comes online? What concessions get made? What strategic options get abandoned? What allies get left exposed because defending them requires military capabilities that China can turn off by restricting material supplies? The dependencies are structural. The timeline for reversing them is measured in decades, and the geopolitical competition that makes those dependencies dangerous is accelerating right now. There's no clean resolution to this. The United States can invest hundreds of billions in rare earth infrastructure and still face supply security questions for the next 10 years. China can restrict exports and damage its own reputation as a reliable supplier, but the immediate leverage is undeniable. The global economy can try to diversify, but the physics and chemistry of rare earth processing don't change based on political preferences. What you're left with is a situation where one of the foundational assumptions of American strategy, that economic interdependence would constrain Chinese behavior, has inverted. The interdependence now constrains American behavior. And that inversion represents one of the most significant strategic shifts of the early 21st century. The next time you hear about rare earth export restrictions, try holding all of these things together in the same frame. The 30-year construction of the dependency, the timeline for reversing it, the military implications, the investment patterns, the alliance pressures, the environmental politics, the fundamental governance asymmetries that made this possible. Because they're not separate stories. They're different angles on the same story. And that story is about what happens when patient strategic planning meets short-term economic optimization. The outcome is not ambiguous. We're watching it unfold in real time.